we're going to learn about are types of, two of them specifically, types of transformations, okay? A transformation is, Avery, a change in the position, size, or shape of a figure, okay? The original figure, this is important, is called the pre-image. The original figure is called the pre-image. That makes sense, because pre usually comes first, right? Like in a movie, if you have a prequel, what does that mean? It's like what comes before the other movie, right? So the pre-image comes first, and that is going to be transformed to the image using one of the transformations that we learn about today, whether it's a reflection or a rotation or a translation or whatever it may be. Okay, and then we use a little prime. This is called a prime symbol to mark the image, and you'll see that here in just a second. So real quick, I want to kind of talk about our umbrella word. What's an umbrella word?
Something that covers like many categories.
Yeah, it's like a word that covers many different categories. My artistic work here. And our umbrella word is transformations.
Do we need to draw this?
If you want.
Roll out.
Transformations. Exactly, like a transformer. Now, the first type of transformation we're going to learn about today is called, now the reason I like to stress this is people confuse these two, is a translation. Which, what word did we use for that? A slide. So those words are very similar, transformation and translation, but transformation is all of the different types. Translation is one of the types. So what other types of transformations did we just talk about? What's another one? Rotation. Good. Dilation. And the only other one is a reflection. So these are all of the words that are underneath transformations. They're all types of transformations. So here you can see an example of a transformation, and specifically, what type of transformation is this? It's a slide. Let's call it the fancy word, the vocab. This is a translation. And notice, the first one is called the pre-image, and it is translating to the image. Now see how, we start out with triangle ABC, and then how do we name the image, the one that it's going to? What's the difference between these two? Yeah, these little prime marks. These are called primes. That's how we know which one is the image and which one is the pre-image. Which one came first? So here is 3 of them. I want you to take a second and read them on your own, and then I'm going to highlight some important words here in a second. So we'll go ahead and read through all 3 of them. All right, so a few things. A reflection is reflected over something we call the line of reflection. That's in your little cheat sheet. And that means all the points are the same distance from that line. So what I mean by that, if I tell you that B is 3 inches from the line of reflection, how far away is B prime? 3 inches. It's the same distance on both sides of the line. Okay, we'll use that here in about 10 minutes or so. Here's a rotation, and once again, this is called the center of rotation. That point that's kind of like the middle of the pinwheel that we're rotating around. Do what? We'll learn. I'll show you how to do that. And then the last one is a translation. It goes the same distance and the same direction. So M goes the same distance and the same direction as L. It's always the same distance and the same direction. If you kind of connect them, it makes like a prism. Fancy schmancy. Okay, now I'll give you a second to write this down. This is not on your notes. Go ahead and just write it down somewhere at the bottom of your page. You don't need all that space, maybe the bottom right. So take a second and write the definition of a rigid transformation down. You need to know that word rigid. Okay, so what type of transformation is number 1? Reflection. Is it rigid?
Yes.
Yes. Number 2 is a
Slide.
translation, and is it rigid?
Yes.
Yes. That means that if it's rigid, that means the pre-image is congruent to the image. Number 3 is a rotation. So if you take it and turn it around each time, literally the recycling sign, it's a rotation. Is a rotation rigid?
Yes.
Yes, all 3 of these are the same size. They face a different way, but they're the same size. And our cute little penguins?
Dilation.
Dilation. And is a dilation rigid?
No.
No. Alright, so here we go. It says identify. This is not on your notes. So just look up here. So what type of transformation is this? Good, it's a rotation. And the way we write it is I'm going to say triangle. Which one comes first? Blue or red? And how do we know?
Red.
Blue comes first
Because the little
because it doesn't have the prime marks. Good. This is the blue is the pre-image. So triangle A, B, triangle A, B, C is rotated or transformed into triangle A prime, B prime, C prime. Okay? Now something cool, to find out how far it rotated, if you take a point and connect it to the origin, that's 0, 0, right? And then you go from the origin to the image of that point. So what's the image of C? C prime. What is that angle? 90 degrees. Yeah. Unless if it states otherwise, for this class, rotations are always going to be counterclockwise. It's just assumed. So if I ask you to rotate something 90 degrees, you're going to rotate it this way. If I ask you to rotate it 180 degrees, you're going to rotate it this way. And then same with 270 is a round and a quarter, right? Yeah.
Is there ever, like how there's one?
So all 3 points. So I did point C, right? Now I'm going to show you how it works with B. So if I go from B to the origin to B prime, what do you notice again? It's another right angle. And then if I take that and I do, the only one I haven't done left is A. If I go A to the origin to A prime, it's a little baby right angle. So all of them work. That shows you how far it rotates. Okay. What is this one? What type of transformation? All those are wrong.
reflection.
It is a reflection.
Oh.
How do we know this is a reflection?
Because it's slid away and it's the same distance away from the line. It's literally like
Tessa?
It's because the letters, the points are on the other side.
Yeah. See, F is the bottom right here, but it's the top right here. If it was a translation, F would stay in the bottom right. Does that make sense? But it reflects over. What did it reflect over? What's the line of reflection? The x-axis. That's called the x-axis. So I would call this a reflection over the x-axis.
Is this on our notes?
Okay, I'm going to skip that. Okay, the next one. This is important. Go ahead and put a little rectangle around this. Or some number. X and Y are X and Y. But you're always going to plug in some number for A and B. And I'm going to show you how we come up with that number right now. Find this example on your notes. I think it's in the bottom right. No, is it?
just right under it.
Oh, it's right under it. So middle left there. Okay. So we have a triangle ABC. And this tells you that we're going to translate it. First of all, they say translate, but this is what it looks like under that cheat sheet on your translation rule. So even if they didn't say translation, we still know this is a translation based on the rule. Okay, so x plus 2. Let me ask you this real quick. Actually, let's take the point. What is C's coordinate right now? C's coordinate is -1, +1, right? Don't write this down. I'm going to show you something else here in a second. Negative 1, 1. Well, what our rule tells us to do is take c and add 2 to the x value and subtract 1 from the y value. So if I take the x value, this is the x value, and I add 2 to it, what's it going to be? Positive 1. And if I take the y value and I subtract 1, what's the y value going to be? 0. That is your new point. So go ahead and plot C prime, which is over 1 up 0 now. Make sure you label. If it's not labeled on your test, it's going to be wrong, because I don't know which one's the image and which one's the pre-image if you don't put a prime there. So C prime. Okay, now let's do the same thing with B. So I'm going to take B, which is, what is B's coordinate? Left 3 up 4 is negative 3, 4. And I want to translate it to a new point that we're going to call B prime. That's the image. So add 2 to the x, and what do we get? And then subtract 1 from the y. And then plot that point.
So it's always going to be plus 2 minus 1.
For this case, yes. They could put any numbers in there, and then you would do that to the x.
Okay.
So that there is our B prime. And then let's do one more. What is A's coordinate right now? Negative 4, 2. Left 4 up 2, right? And we're going to translate that to a new point we're going to call A prime. So take negative 4 and add 2. Get negative 2. And then take the y value and subtract 1. 1. Plot that point, negative 2, 1, and call it A prime. And then connect all 3 of your points, and what do you notice? Is it the same triangle? Yep. It just moved down a little bit, down into the right.
So it could be overlapping?
So what do you think, is this telling you to go right or left? Left, because it's negative. Left 2 is what that means, right? Take the x value and move it left 2, okay? Now we have a y value. What is this telling me to do? That's telling me to go up 4. Plus 4, right? Y plus 4 is up 4. So take all 4 points. This isn't on your notes, but just watch. All 4 points, because it's a rectangle, and take each one, move it left 2, up 4. So left 2, up 4 is J prime. Left 2, up 4 is K prime. Left 2, up 4, that's M prime. Left 2, up 4, that's L prime. There's that exact same rectangle moved left 2, up 4. Okay? All right, go ahead and read the directions on this one, and I want you to come up with the rule yourself. So use your little cheat sheet. You have to write it in the correct form. Tell me how I would translate hexagon 1 to hexagon 2. Okay, go ahead and do that on your own. So you always start out with xy. That represents all of the points. And then you need to tell me what I need to do to those points. So you're coming up with the A and the B values for this. So why is it minus 3? Why minus 3?
Because you're going to the left.
Yeah, we start at A, and we go left 3, up 1.5. And all the points, they give you A, but they should all do the same thing, right? So if I go from here, it's left 3, up 1.5. And then you can see that corner of the hexagon goes to there. Left 3, up 1.5. So all of them do that same thing, okay? All right, so the last one we have to learn about today is a reflection. Now take a look. All of these are on your cheat sheet. So look at your cheat sheet under reflections. They're all right there.
There's so many.
What does your cheat sheet tell you to do to the point xy in order to reflect it over the x-axis? Yeah, reflect x-axis. It says xy needs to turn into x negative y. So x negative y is our rule on your cheat sheet on how to reflect over the x-axis.